Hi guys, today we're going to talk about video lesson 1.7. Has to do with geometric applications. Geometric applications are when we take a concept like polynomial operations and we combine it with geometry concepts. And we've done this a little bit already, but we're going to do a few more examples together today. The first one, A, says determine the area of a square that has a side length of x plus 3, and leave your answers in simplest standard form. Remember, standard form means that the exponents are written from highest down to lowest. Well, we know that a square has 4 congruent sides, so all of the sides can be represented by x plus 3. And we also know that area is length times width. So to find the area in simplest standard form of this square, we would multiply the length, x plus 3, times the width. Now today in class we practice multiplying binomials by double distributing. X times x gives you x squared. X times 3 gives you 3x. 3 times x gives you 3x. And 3 times 3 gives you 9. Combining your like terms, the area in simplest standard form is x squared plus 6x plus 9. Okay. Letter B says determine the area of a parallelogram whose base is 2x squared plus 3y plus 1 and whose height is x minus 5y. And leave your answer in simplest standard form. Now a parallelogram could be a square, because a square has opposite sides parallel and congruent. Could be a rectangle, because a rectangle has opposite sides parallel and congruent. But usually when you're talking about a square or a rectangle, you use the terms length and width, not base and height. So my assumption is that they're talking about a parallelogram that looks like this, even though this doesn't really look like a parallelogram, where this is the base, and the height is the distance between the top and the bottom. Regardless, the area of a parallelogram is also found by doing base times height. So to find the area of this parallelogram, I'm actually going to put this smaller one out front, x minus 5y. I'm going to multiply that by 2x squared plus 3y plus 1. Now this is a binomial times a trinomial, so it's going to take a little bit more work, but we're going to solve it the same way we did this one, only we're going to triple distribute. X times 2x squared gives me 2x to the third. X times 3y gives me positive 3xy. X times 1 gives me x. Now I'm going to take the negative 5y and distribute it through. Negative 5y times 2x squared gives me negative 10. I'll put the x squared first and then the y. Negative 5y times positive 3y gives me negative 15y squared. And negative 5y times 1 just gives me negative 5y. Now let's see if there's any like terms we can combine. If I want to put this in standard form, that means I have to go from the highest exponent down to no exponent. It looks like this has an exponent of 3. We'll put that first. 2x to the third. So I took care of that one. I'm going to put this one next because this also has an exponent of 3. Even though there's two variables, this one has an exponent of 2, the y has an exponent of 1, and 2 plus 1 is 3. So we'll put this one up in front as well. Negative 10x squared y to the first. I see I have a negative 15y squared. This term here also has an exponent of 2 because it's x to the first times y to the first. Add those together, you get 2. So I'm going to put plus 3xy next. And then I have a plus x and a minus 5y. There's your final answer. Now what about a triangle? We're going to determine the area of a triangle whose base is 5x plus 4. Oh, and that should say, and whose height, not base, is 2x plus 3. I don't know if you remember the area formula for a triangle, but here it is. It's base times height divided by 2. So to find the area of this one, we're going to do 5x plus 4 in the top times the height of 2x plus 3. We're going to divide that all by 2. When you distribute up here, 5x times 2x gives you 10x squared. 5x times 3 gives you 15x. 4 times 2x gives you 8x. And 4 times 3 gives you 12. All divided by 2. Combining like terms, we end up with a 10x squared. 15x plus 8x is 23x plus 12, all divided by 2. And you're done. You found the area. Now, if you wanted to, you could rewrite this way, and it would be equivalent. 10x squared divided by 2 is 5x squared. 23 divided by 2 is 11.5. So plus 11.5x. And 12 divided by 2 is 6. So plus 6. If you wanted to divide each term by the 2, that would be fine too. If you hear noise, it's my dog. He's under the bed and he's eating all the fabric that's stapled to the bottom of my box spring. And he's also playing with a squeak toy. So if you hear funny noises, that's Murphy. Alright, letter D. A rectangle has a width of 2x minus 2 and a length of 5x plus 3. We're going to find the area. Again, the area is length times width. 2x minus 2. We're going to multiply that by our 5x plus 3. And we're going to simplify it. So let's double distribute. 2x times 5x is 10x squared. 2x times 3 is 6x. Negative 2 times 5x is negative 10x. And negative 2 times 3 is negative 6. In standard most simplified form, we have a 10x squared. We can combine a 6x minus a 10x, which gives us negative 4x, and then minus 6. There's the area in its most simplified form. Now, the second part of D says find the perimeter. As we talked about a couple classes ago, perimeter is when you add all the sides. And if you remember, in a rectangle, if we have a rectangle that has a length of 5x plus 3, well, it's got two lengths of 5x plus 3. And if we have a width of 2x minus 2, well, a rectangle has two widths that we're representing with 2x minus 2. So the perimeter would be 2 times the length, because there's 2 of them, added to 2 times the width, because there's 2 widths as well. In its most simplified form, we would have to distribute. 2 times 5x is 10x. 2 times 3 is 6. 2 times 2x is 4x. And 2 times negative 2 is negative 4. Combining like terms, 10x plus 4x is 14x. And 6 minus 4 is 2. There's your perimeter in its most simplified form. So looking forward to class next time, where we're going to start reviewing for our Unit 1 test. Have a great night.